New Year, and welcome to this, at least for our department, first inaugural professor lecture. I look very much forward to Henrik Klinge Jacobsen's lecture on energy demand. We will have 1 hour now on deep insights into this fascinating area, and afterwards you are very welcome to raise questions to Henrik. And then we'll have a small reception outside. Henrik, who is Henrik? He has a master in economics from the University of Copenhagen from 1990. And he also has a PhD degree in energy economics from the same university from 2000. He was employed as researcher at the Systems Analysis Division at Risø National Laboratory in 1993 and became senior researcher in 2000, at that time DTU. His research profile ranges from integrated energy and macroeconomic models to electricity markets and renewables with fluctuating generation and coupled with a variety of support schemes. I guess that we will hear a little bit about that. In the area of renewable energy, Henrik has participated in a long range of international and European projects about integrating renewable in the electricity grids in an efficient way. The fluctuating generation characteristics of some renewables, as for example wind power or PV, have called for analysis of the options to accommodate this in at least cost fashion. Support schemes for renewables and other environmental regulation interact with the power markets and the security of supply, and this has been a recent focus of his research. Henrik has published in energy economics journals on issues such as energy demand in macroeconomic models, decomposition of energy demand developments, focusing on foreign trade contribution, and distributional effects of a long range of energy and environmental taxes. Henrik is engaged in the Nordic 5Tech Innovative Sustainable Energy Engineering Program. He also collaborates with the University of the Faroe Islands, and he has taught at courses in Malaysia and at Comilla University in Madrid. His teaching activities include 6 years of energy economics as a core course of the Sustainable Energy Master at DTU, and he is also responsible for coordinating the Master in Sustainable Energy at DTU. So with these words, Henrik, the floor is yours.
Thank you very much, Birte, and thank you to all of you for coming here. I'm happy to see you. I will today talk to you about energy demand. I'll talk about incentive regulation and one of my focus areas that I had in distributional impacts of instruments and especially taxes. So the talk will be divided in two. The first one will be an applied analysis looking at a case in Malaysia. Probably some of you will see that the pictures at the front here, they relate a bit to that situation, and it relates to the situation where you have rapidly growing economies at the right, and you have environmental issues and reserves and life that's a bit well, looking at this development, not very certain that they will survive. I will talk through the agenda. I will have these two areas, which is the first, energy demand structures and energy intensity. With rapid growing economies, and some of them also in developing world, there are often issues about energy subsidies, high energy subsidies, and I will illustrate that with an application from Malaysia. What happens when you try to remove subsidies? What happened to different industries the relative competitiveness of the industries and towards the competitors abroad. Moving from that first application, the second one will move more into the regulatory instruments, going through the list of instruments we could use to increase energy efficiency, savings, and substitute the energy used towards more environmentally friendly resources. These instruments all have impacts that are distributional impacts on households. And that's what I will show and look at in the next part. I will look at the distributional impacts of taxes, especially. Doing that, I will look at the Danish case and the effect on households relative to the Malaysian case where it's industries. So comparing the different environmental taxes, we can use the marginal Gini, or we could use Zoot's coefficients. And I will illustrate what the results are when you use these different measures. Starting my talk, I want to just stress that why do I want to focus on energy? I focus on energy, and I did all my work on energy because energy have provided growth and welfare by increasing productivity and supplying essential services to all of us, to mankind throughout time. However, of course, the second point is that the environmental impacts of the energy use, they are often associated with potential harmful effects, and furthermore, the fossil resources are scarce, the resources limited. It even goes for the cheap renewable resources, they are limited as well. So we all probably want to have more of the first with less of the last elements. How can we deal with that? Using instruments, we often look at changes in prices using economic instruments. Here, I will start looking at industrial structure. Energy intensity is very different in all the economic sectors. It depends on the kind of production you have to undertake in each sector and the necessary processing steps that you have to do to produce the commodities. Therefore, any effort that targets to increase efficiency, hopefully, or just the direct impact when you impose taxes, raise prices, they have effects on the relative position of industries. So we have to look at the competitive outcome for industries when we want to change these instruments. Now, Denmark is a bit boring sometimes if you look at the situation where we have very stable energy consumption growing slowly. So what about looking at a different situation? Malaysia. How important is it in Malaysia, where we have very fast growing economy, high growth rate for energy consumption, and at the same time, the energy intensity, the dependency on energy is very high in an economy like that. I take the point of 2005, where Malaysia was facing a substantial challenge with regard to having high intensity and high subsidies on energy at the same time. It had not been that big problem where energy demand was, well, it was not at a very high level, and Malaysia had sufficient own resources to support that subsidy. But Malaysia has very high energy intensity and it's growing very fast. That means the total energy demand is increasing fast as well. At the same time, they were subsidizing heavily, especially some of the new resources, natural gas. Globally rising energy prices led to increasing or lead to increasing public spending and a deficit from subsidizing. So the public budgets were experiencing deficits, and that was creating, well, a need to do something. This was difficult because there was a lot of fear of harming export industries, and that prevented that you adjusted subsidies fast. So that was really the trap that authorities had got into at that time. So the objective of the analysis is to quantify the cost effect, and that will be just the immediate short-term cost effect for different industries of fuel subsidy reduction, and to see if we could really get rid of this fear of harming industries, harming export industries. So what was the situation for Malaysia? Well, Malaysia was here at the left axis. You will see the net import of energy, total energy in physical terms. So looking at this situation, Malaysia was a net exporter originally, quite large net exporter, but was looking forward to a situation of becoming a net importer around the years of today. Not very different from possible development that Denmark was facing and are facing maybe now at a later stage. But the situation and the projection really showed that it would become a large net importer in time. If you look at the self-sufficiency, that's the blue line here, it crosses at the same point, but what Malaysia was looking forward to was that it would only, with own resources, sustain like 50% of the domestic consumption of energy. So it would really face a dependency on foreign oil imports, energy imports. So we used just a standard input-output calculation. We looked at input-output tables from 2000, 94 by 94 sectors and commodities. The matrices had to be expanded because we were looking at the possibility to change both electricity prices and natural gas use, the price for use in industry. So we did split the natural gas and electricity industry into two, and we wanted to have also the most recent developments with a quite large expansion in natural gas use included in the analysis. So we had to combine with national energy balances for Malaysia to calibrate total energy demand on the fuel types and for a projection of the gas intensities. The manufacturing survey were needed to divide energy use on subsectors at the more disaggregated level and mapping this different classification to the national account classification. So we had energy intensities constructed for all natural gas and electricity subsectors. Matrices with domestic production and the corresponding import commodities were used as well. And then final demand, the different final demand components distributed on all the 95 commodities, domestic and imported. A lot of data. And first, I will illustrate what is the structure. The structural difference, how much does it matter? How big is the difference between sectors? And looking here at first the economic importance. This is value added, the first column, value added in manufacturing, the composition of value added. So a very large sector in Malaysia, that's the machinery industry. 50% of total manufacturing. So this is what matters economically to Malaysia. Looking at another small sector, that's the cement industries, primarily. They constitute just 4%. So they're not very important with regard to economy for the country. However, as soon as you turn to the energy use in these industries, we will have that machinery, well, it now only consumes 30% of total electricity, and the cement industry consumes 7%. So already for electricity, the cement industry is becoming more important than it was just for the economy. Looking at natural gas, it's even much more different, because here we have 20% of natural gas consumption is really in the cement industry. So for all projections, all analysis of cost changes, subsidy changes, the cement industry is really important. If we raise prices here, they will probably also be impacted quite a bit. In total, we end up with that the two industries, which were like 1 to 10 in size economically, turn out to require around the same amount of energy for its output. So they are equally important for energy purposes, but not that much for the total economy. Looking at electricity intensities, these are just as different. This is now looking at electricity intensity, measured here as TOE per million Malaysian ringgit fixed prices. And it is both some historical data up to 2002. So it's 4 years of historical developments for intensities, and then it was a projection made at another time. This is looking at machinery. That's around 30 TOE per million Malaysian ringgits. So that's the intensity of electricity used in that sector. If you compare it to iron and steel, which is at the top here, and look at the right axis, because I had to put iron and steel at the right axis, it's 15 times as intensive in electricity use. So that's a huge difference. It's even larger than the differences you will observe, or quite more different than what you would see for Denmark. But it's so important that you include these differences in any kind of modeling and any kind of analysis. Doing the analysis at the aggregate level will produce false results. So the IO calculations we did was simply, we made an assumption about what would happen if we removed subsidies. First, say that subsidies, well, the change in natural gas prices was that we tripled in this exercise to triple natural gas prices as input in electricity, because they were the most subsidized. So we raised the natural gas prices to world market levels. It was not a world market gas price, it was the alternative that Malaysia had. It could export the natural gas in the form of liquefied natural gas with some losses, but the price that they could gain as an alternative, that was used for the targets that we wanted to change the price to. So 200% increase in natural gas prices, and then it ended up with, if we passed all the costs, which is not a long-term likely outcome, but just the short-term cost impact, then it would mean that cost for electricity generation would go up 32%. How can you do that in a power system? Well, this is not a liberalized power market where you have some market establishing prices. This is a regulated, controlled electricity price system. What are the results? The largest impacts you could observe that are that raising these natural gas prices 200% means that cost for production of ice goes up 5%. So that's the maximum possible impact you could have on the ice. We have this as an input-output calculation, which means that we have both some direct and some indirect effects. Illustrating it with the red circles here, we have two cases. The first one, looking at other chemical products, where we have that the direct effect, that means producing other chemicals, we need natural gas and electricity, that will raise cost 2.2%. If we include all the inputs from other sectors, to the production of other chemicals, we end up with 0.5% additional cost. So here we have what is the general picture, that the direct effects are the most important. If we look at the case on the bottom, it's a bit the opposite way around, that indirect effects are larger than the direct effects. So both is possible. So this is like the negative impacts you could have, or the costs, immediate cost impacts you could see. But what are we more interested in? Probably we would prefer to look at the export industries relative to the domestic industries. So if we do the calculation for all the final demand components, we will have the private consumption here will experience a cost increase, or will become more expensive, depending on all the behavioral stuff later on. But first of all, the immediate cost impact would be an increase of cost of 1.80%. Not that much from a 200% gas increase. But if we compare it to what is here important, the export industries, they will not be as much impacted as private consumption. So in this case, the structure of the economy, the structure of production, and the energy intensities means that the export industries are really less exposed to changes in natural gas prices. So based on this, we could draw some policy advice to the authorities, to the government of Malaysia. And the conclusion is that as Malaysia controlled all the energy prices at that time, it meant that natural gas prices, they could be increased towards world market level without serious immediate effects on cost for exporting industries. Electricity prices should be allowed to follow some part of it along the way to increase also the electricity prices corresponding to the cost increase. This has to be adjusted if you look at what are the substitution options within the sectors, of course, and also when you look at what is already the situation with regard to the regulated power price. All this will, well, first of all, it will be an economic benefit, as we have the too low prices in Malaysia for natural gas resources that could be used elsewhere is an economic loss. There is an inefficiency that you do not charge what is the alternative value somewhere else. So that's, of course, generally the general loss that you could avoid or get rid of. But for Malaysia especially, this would reduce the needed government subsidies and the deficits that were really a problem at that time. Well, probably Malaysia could find some much more productive use for all the spending, instead of spending on the subsidies to spend on something else, more productive government spending. And then they could reduce excess energy consumption. There is also, of course, no incentive for energy savings or to substitute between energy types when you have these very cheap natural gas prices. Finally, there is this problem about the trade balance caused by the net import status that Malaysia will have later on. And then there is, for renewables, something we probably, a lot of us also are interested in, that the renewables will gain their fair competitiveness advantage, or it will have a better position relative to gas-based power. And here we will probably see something happening in Malaysia. This was the end of the story about Malaysia, which was an application for industry. The importance of the structural differences in energy intensities. Now I will turn to the second part, which is about the incentives you could use to regulate energy demand to incentivize both savings and changes in the composition of energy consumption. So first, incentive-based are the economic instruments. We have taxes and duties, tradable emission quota systems. Well, you can always argue under which conditions the first is the best, the second is the best. And we have finally the third element. You could choose to support investment support, production-based support to renewables, or support to saving investments. All these are the incentive economic-based instruments. We also have command and control instruments. And I will always say that just as often you can find cases where the command and control instruments are better compared to the economic instruments, but there are also cases where the economic instruments work much better and more broadly. Now I will go to the household part of the story. What happens for the households when you use these instruments? What happens to households when you use taxes and duties? Is there any unwanted distributional impact on households of using taxes? A lot of people have suggested that, and that has sometimes prevented us from using the taxes. I will investigate that here. So looking at distributional impacts, tax incidents, if it's a little broader analysis, here I will focus on household tax payments, energy demand in households causing a lot of tax payments, plus the indirect effects from taxes that energy and environmental taxes imposed on industries that produce consumer goods. The study I'm referring to or using here was a study that, contrary to many others, were examining a lot of already implemented taxes. That means it's taxes that you're actually paying. You have experienced the tax for some while, and you have adjusted, partly adjusted to the new tax rates, so that the behavioral change effect has already taken place. So that's an analysis of the distribution of tax payments, not a hypothetical case where you analyze what is the effect of a broad carbon tax imposed on all the carbon contents and all fuels, but without any real knowledge about what happens to actual payments in the end. So using taxes and duties as incentive for savings and emission abatement, why should we consider distributional impact? It's always important because equity concerns matters a lot for acceptance. If we should have policies accepted, including both taxes and any kind of support schemes as well, we will have the challenge to make people accept that they do not have adverse effects on low-income households, that it's to the benefit of also the lower-income households. And therefore, we should look at what is actually the distributional impacts of these taxes. And you could say that environmental taxes can be designed in ways that has less problematic distributional effects. This is maybe not the best solution. An even better solution is that when you do these green tax reforms, we have to look at tax recycling as well. If we have changes in green taxes that have adverse effects or problematic effects on the distribution of tax payments between households, then we should try to compensate for that when we reduce other taxes. We often compensate a lot of industries because they can claim that they lost competitiveness, so we compensate them when we make tax reforms. We should also, to some extent at least, compensate if there are adverse effects on low-income households on their tax payments. So what are we including here in this analysis? We are looking at direct impact by tax payment and the indirect. So that's the domestically taxed produced goods and services. I put a line here because you might just as well say, well, why don't you put it even broader than that? You could say that there are employment effects of the policy changes or policies, and you should include these because they can be good for maybe lower income households, but maybe not. We also have tax structure interaction. It's that if we include policies where we increase green taxes, we do not know whether or not that will cause any interaction with other existing taxes. Efficiency equity trade-off is always a concern here, because if we make less uniform taxes because we want to take care of this distributional problem, then we often lose some of the efficiency in terms of the environmental gains we want to target. Finally, but not least, I would say that distribution of the benefits is just as important, because all this talk about distribution, in fact, from the taxes, that has to be balanced about with the possible benefits you can get if we reduce environmental problems. We reduce pollution and maybe health problems. So what is the situation? The situation in Denmark was that we had a composition of taxes, total environmental taxes, like this. We have households. For most of the taxes, households are paying the larger fraction of the total tax payments of these kind of taxes. So for petrol, households pay the larger fraction. We have electricity, household pays the larger fraction as well, and even for weight duty. So for most taxes, it's like that, but also industry pays some environmental related taxes. So it's important that we could address both the direct tax payments by household, but also the indirect that they are exposed to their consumption of domestically produced goods. There are a lot of empirical studies on this in this area. We have here at the bottom, I have the two studies that I draw on when discussing it here. That was the study we did reported in 2003 and 2005. These two papers report the results of the study at that time. Here I have two additional studies. First, one for Spain that finds, using a microeconomic household demand model and some CGE on top of that, they found that a flat carbon tax is found to be neutral due to including transport. But this is a hypothetical tax as well. This was not an implemented tax. For the US, carbon taxes are also found to be regressive, and they also look at the input-output part, where they look at direct and indirect effects. So they find that the directly part is more regressive than the indirect part. So I'll compare to that with our studies just in a short while. So what are we looking at here? This was a broad study with examining tax payments for 22 already implemented taxes. We are well known around for implementing a lot of environmental taxes. And here, 22 of them are examined. It was a very large data set based on the Danish law model, which have approximately 3.3% of the entire population of Denmark included. There is a lot of income data in this database. Of course, a lot of tax payments, but also information about where you have your location, your workplace, which type of car you have, a lot of information about your properties, and the size of the property you live in, and the value. So there are a lot of information you could use for characterizing households and see what they consume of energy. But you need the energy information. So we combined this data with electricity, natural gas, and water consumption from large supply companies. It turned out that we could individually match the address of the people, so that 50% of this large sample up here could be matched with actual consumption data. So you had real consumption data for electricity and water. So that was really giving the basis for the direct energy consumption. And we could distribute then on households characterized by income, by size of the households, by number of people living there, a lot of other socioeconomic characteristics. But for the indirect part, we needed something more, so we used the consumer survey from Statistics Denmark to identify the consumption bundles for all the income brackets. Looking at the composition of consumption on the entire consumption for the households, 3,500 households. This also classified according to income, and we could match, to some extent, we had a lot of procedures, matching the characteristics with regard to consumption bundle with the income grouping from up here. Finally, for the input-output calculation, we needed the taxes on businesses. So we had the actual tax payments from all the businesses. It was not like one tax rate for the businesses. No, it was the actual tax payment from each industry. A lot of exemptions exist. When you tax energy use in industry, well, a lot of industries get exemptions for different reasons, mostly as efficient lobbying work. They get a lot of exemptions. And that was included in the material. So it was actual tax payments, not a flat rate. So that was included in the input-output calculations and 130 sectors. Final demand was 72 consumption commodities, including 5 of them as energy. What are the results? This is just showing the graphs of the income deciles that we were working on. Here we have on the vertical axis, we have the tax share of disposable income. This is giving the result or the shares for total environmental taxes and based on the disposable income. So it's disposable income in the deciles. So here we have first lowest income decile, consume products that are taxed in a way that 8.5% nearly of their disposable income is used for paying these environmental taxes. So that's quite a large share of their disposable income. Because environmental tax revenue constitutes around 10% in total of Danish tax revenues, it's also quite large here, of course, for the households. But if we end up here at the last income decile, we have that the richest, they actually spend less of their income on these environmental taxes. It's not much less, but it's like 6.5% compared to 8.5%. So it is less. It's not less absolutely, because that's what you will see in the blue columns, that the actual tax payments in euro on this axis are given here, and they are, of course, rising. So the nominal spending on these taxes is rising with rising income. In all these groups, we have that there's an equal number of persons. So here we have equal number of adults represented as we have here and here. So these are equal along the income decile. So that was the total picture. What does it tell us? It does tell something about that, well, maybe there is a small regressive effect on the tax payments, or that at least that the high income groups pay a smaller fraction of their income on these taxes than the low income. But again here, the differences matter a lot, because there is very large difference among the different types of taxes. Looking here at 3 categories. We have transport-related taxes, green taxes, and energy taxes. If we take the transport taxes first, all the transport-related taxes, now again as a fraction of the disposable income for each group, for each income class, then we have that transport taxes actually constitute a rising share of their disposable income. So that tends to be more progressive than what you can observe for the 2 others. Looking at the green taxes and especially energy taxes, they show falling pattern. That means in the low income groups, they spent like 2%, 2.7% on income on energy taxes. Where you go to the high income group, they spent only 1%. So here the regressive pattern seems to have been, or is much more pronounced. So that was the different taxes. Now, to be more certain that we have a correct measure here, we followed Poterba and Metcalf and others that suggested that instead of using the transitory income for 1 year, that changes. So maybe people, well, they adjust their consumption not based on the transitory income for 1 year, but they look at the longer term and expectations about what they will earn, and even they also consider their wealth. If they have some wealth, they could spend on consumer goods that are taxed like this. So looking at something which is more a proxy for lifetime income, we could take total expenditure. So for comparison here, we are calculating the shares based on total expenditure for each income group. So this is just a check on the robustness of the results. What happens here is that for transport-related taxes, instead of having just some rise in the shares, we have a much more pronounced increase in the shares of taxes out of expenditure. So what happens to the other 2 categories of taxes? It turns out that they become much more flat, so they are nearly neutral. Why is this development quite logical? It is, of course, because if you go for the higher income groups, they have much lower, or they have much higher savings rates. So savings rates are high up here, and they are low down here. So naturally, you will make all the taxes look more neutral or progressive using expenditure data. Personally, I think you should maybe be somewhere in between, and it would be very nice to be able to look at lifetime income instead of looking at either 1 year of income or looking at expenditure. So that was the result with regard to this. This is an illustration of the direct and indirect effect. The direct effect is up here. And this is just illustrated for the carbon tax at that time. That the direct effect, that's what the households pay themselves, which was on the electricity bill, whereas, or mostly, and then the indirect effect was on the payments that industry had to pay at that time. So both the effects are given here. The indirect is the smallest, and they both show a regressive pattern. So there is no real big difference between direct and indirect here. But this was just giving all the graphs. We would need some measure, one measure, if we should compare the taxes. So one measure we are looking for that could compare each of the 22 different types of taxes. So calculating one measure, we could use the Gini coefficients from collection an equal amount of tax revenue for all the different taxes. So we could use a marginal Gini coefficient calculated this way, and we can compare all the taxes. And we will do that for household income or to some extent for the expenditure data as well. But finally, we will again do the alternative comparing with the Suits index, which is another different measure with a little bit different weight to the different income categories. So the Gini is basically the pattern here where you have the accumulated income up the axis and you have the number of persons of the population up here. So we have the 10 income deciles up to the full population we have and the full income up here. So equal distribution means following the 45-degree line. Calculating the Gini is looking at what is the actual accumulated disposable income for this category up to here. For all 10 categories, calculating this area compared to the entire triangle below the 45-degree line. Doing that with our data and with the disposable income minus the indirect taxes, we end up with a Gini of 21.2. So the marginal Ginis. Now we want to compare different taxes. So here we have the blue line is the disposable income Gini before we deduct the indirect taxation. If we deduct indirect taxation, we end up with a dotted line here. And the difference between these two lines is the difference between the two Gini coefficients. So in this case, indirect taxes increase the Gini coefficient. It makes the consumption possibilities more unequal or unequal. This was done for all taxes, an equal tax revenue collected and done for all the taxes. What turns out here to be the results is a comparison of all the different types of taxes. We have that and can observe that the only ones that seem to be progressive are the transport-related taxes. Petrol have a negative impact on the Gini, so reduces inequality. All the others increase inequality. That was the first observation, confirmation. The next one is comparing environmental taxes to other taxes. If you have the total environmental taxes here compared to value-added tax bumps, then it turns out that the environmental taxes are less regressive or have less regressive effects than VAT. So they are better, you could say, in terms of redistribution. That was the first measure. The second measure is the Suits index. Here we do it in a little bit slightly different way. The so-called modified Lorentz curves are now looking at the accumulated tax. So that's the accumulated tax payment here up the axis. And at the horizontal axis, we have accumulated income, not persons. So here we end up with that the 50% of the persons are actually around this part of the distribution, which means that if you're using the Suits index, I'll tell about that, then you get a smaller weight to the low-income households. The Suits index is calculated a little bit different from the change in Gini, the marginal Gini, in the way that you look at the area up here, which is the VAT, where you have that if you take, like, let's say 30% of the accumulated income for, we'll take something where we can find a point, because this is a point. This is an income decile. So looking at 27% of the total accumulated income, they pay around 35% of the total taxes, the VAT. So this is actually a regressive tax, whereas the petrol down here shows that the low income group, was it 27 again here, 25% of the income pays only 20% of the total taxes on petrol. So this is another measure with a different weight. Comparing the robustness of our results, we get that, let's say for petrol down here, we have the marginal Gini negative. That means it's a progressive tax. The Sood index is positive. It's a progressive tax. Still here, we're lucky that the marginal Gini based on expenditure also shows the same. So they are consistent that this is a progressive tax. But even more important is that the ranking between the different taxes is the same. If you use marginal Gini or Sood index, you get the same ranking. If you look at what is progressive here, you get the same over here. If you look at the most, if you look at direct and indirect CO2 tax, at this point, you get a regressive effect here, a regressive effect here. Well, with the expenditure, it's nearly neutral. But using the two different measures, marginal Gini or Soods, they are nearly equal. Concluding on the findings here, we end up with that environmental taxes in Denmark are found to be regressive, as probably in most other countries. However, which is important, they are no worse than other taxes. They may be even better than value-added taxation. And they're much better than the taxes on alcoholic tobacco, which was included in the analysis too. The distribution impact varies among the different environmental taxes a great deal. Electricity and water, they are especially regressive, as opposed to transport, which is progressive. This is, standing alone, an argument for maintaining the transport-related tax weight in the total environmental taxation. I will stress a lot that the benefits from reduced damages caused by pollution and climate change will tend to benefit the poorer households more, and this is probably more than offsetting any possible negative effects of tax payments. That was my two applications in energy demand, so thank you.
Questions? Please present yourself, Peter.
My name is Peter Marbom from the Danish Energy Association. There's a lot of discussion both at the European level and in Denmark about the cost of the green transformation, and especially in Germany there's a discussion about do the German consumers have the money to pay for the increasing taxes on electricity and things like that. So what would you answer? What would your input be to that discussion? I mean, is it just rubbish, or what should we do about it?
Yeah, my answer is that in Germany they went one way, that they put the major part of costs for the support for the renewables directly on the consumers and exempted to a large extent industries. This is one way to go. I'm not sure we should move the same direction, but in relation to my results, I can add that what comes closest to the distributional impact of these public service obligation payments, that's probably the results we got for the carbon tax, if it's in Denmark, where both industry and consumers pay. Then you would have, well, the slightly regressive effects from CO2 taxes. In Germany, where you put the taxes entirely on the consumers, I think that that will, of course, be much worse for the consumers.
I have another question here.
Thank you, Mr. Nielsen, DTU. My question is maybe not so energy related, but You were very interesting results and comparisons with transport taxes. The current discussion concerning road pricing, which I believe will be in the order that we should pay the same price per kilometer, whatever income we have, wouldn't that completely change the, say, progression of that tax?
I think that the road pricing is a very efficient instrument if it works technically and the costs are not too high about using it. Then I think because you can target both the environmental pollution issues at the same time as you target those places where you have too much transport. And I don't think that the distributional effects will be very much different, because when you look at who is driving, well, the people that are driving the longest distances today, that's probably some of the richer income groups which pay relatively high taxes in this way. If you go to the new system, I think that you would have people that are driving to their workplaces in the cities, very much within Copenhagen, for example. That means they will have to pay relatively much, whereas a lot of the low-income groups, they are in the countryside. So they live in the countryside, and you will not have the same extent as costs from road pricing there, because you do not have the same problems there. So the taxation through road pricing will probably be much less in rural areas where there is no pollution cost, or the pollution effects are less than in urban areas. And I don't think you should expect that road pricing means that you pay equal for the amount driven. That's not the purpose why we should use road pricing.
Yeah, we have. Is it a follow-up question?
Just a thought I have, that I think you should pay the same amount per kilometer in Copenhagen, irrespective of your income.
That's correct, of course.
So
yes.
whereas a rich person will probably drive today in a big high-tax car. So intuitively, but maybe I'm too quick on that. Thank you.
Yeah, that's correct. If you are living in the city and you're driving around in the city, you'll be paying for driving on the same roads, the same time, no matter your income. That's correct. But if you look at what are the low-income households, either they don't have a car and live in the city, or they live in rural areas where they will not be as exposed to the road pricing taxation.
It will very much depend on where people live and work also. And I can't give a short answer to that. Now my question is very simple. What are the main arguments for the environmental benefits from energy taxation are higher than or are more progressive and more than compensating from the regressive effect of the taxes?
I think that a lot of the pollution problems with particles, if you look at also some of the effect from NOx, etc., in urban areas where you have in those areas which are quite polluted, maybe not that not very much in Copenhagen, but in many cities you have that low-income people live in areas that are quite close to roads where there is a lot of traffic, so they are exposed very much to pollution. And if you get reduction in this kind of pollution, that will benefit those population groups the most. So I think that's why I would expect that improvements in environmental conditions, they will be most for the lower income groups. The same goes for a lot of the, if you talk about climate change and options for adaptation, that if you are richer households, it's much more easy to adjust to changes in environmental conditions. If you talk about global warming effects and flooding and higher sea levels. If you're rich, you can much more easily adapt to that than if you're a poor household.
Yeah.
My name is Nikolaj Rasmussen. I'm a master's student here at DTU. Do you see property taxation as a possible method to get going this energy renovation we are hopefully facing in the next 20, 30 years?
Oh, that's a little bit different from this here, but I think that property taxation is, of course, one way. It's been experienced somewhere that you get tax deductions for investments in energy savings in your houses. So you can deduct in your income taxation or in your property taxation investments in energy savings within the house. And it is one of the options that have been used somewhere.
But how do we relate it to the energy class of the house, for instance, as we have with cars?
Yeah, it is also an option to do it with the property taxation. Say that if your energy class for your property is better, then you pay lower property taxes. It is something to be considered. I think it will be very difficult because I don't think that then you have to believe, or people have to be able to question if you have the right energy class on your property or not. And that could make it a bit bureaucratic. But in principle, it's worth considering, yes.
Paul-Erik Morthorst from Systems Analysis. Henrik, I suppose that the progression you find in transport and regression in environmental and energy taxes, this pattern is almost the same in other European countries. But actually, if we look at Malaysia, would you then find an identical pattern, or how would that be?
Yeah, there are two things with Malaysia. That, well, if it's a developing economy, that means that you have a lot of growth in transport as well. And if you look at petrol taxation, it will affect like all the households which are in the middle income groups, because that's those people that buys the new cars. I don't think you will affect very much the low income groups because they don't buy the cars yet. They drive two-wheelers or they take public transport. But you will affect the middle income group, so I don't think it will be very regressive. It will not turn to being regressive. If you look at the US in comparison, in the US you could even find that transport taxes on petrol, etc., can have regressive effects because low-income households also there live rurally, and they all have a lot of cars and drive a long distance for work. So in the US maybe it's not as pronounced as here.
Should give Henrik a big applause now.
Thank you, Birgit.
And now there's a reception outside, and the discussion can also continue.